In order to find the zeros of a function or the x-intercepts or the parts where the graph is going through the x-axis, if I want to show you, it's going to be these parts where, for example, if this is our graph, these 2 points, x1 and x2, are going to be the points that we're looking for, the x-intercepts, the points in which y is 0, or the zeros of the functions, or the parts where the graph is going through the x-axis. So in order to find these 2 points, there are different ways. The first way, there's no first, second, or third. If I want to just put them in random order, it would be factoring, it would be completing the square, and it would be using the quadratic formula. Quadratic formula and completing the square works for every case. So if the question doesn't specifically tell you to factor or do anything specific, you can use completing the square and a quadratic formula for all the cases. But if the question specifically tells you to factor, or if factoring seems much easier and faster for you, you can factor. So factoring has its process too. Factoring goes through these 3 steps: GCF, special cases, and then FOIL. So look, for example, I'll give you something like this. It says find the x-intercepts or the zeros, or solve. These are all the same thing, using factoring. If I give you this, then you are supposed to go with factoring, and it's going to be 5r squared plus 23r plus 26 is equal to 0. That's the question. In order to do this, you need to go through the process of factoring. What is the process of factoring again? It's GCF, it's special cases, and it's FOIL. In this case, there are no GCFs. It doesn't have a GCF. It's not a special case because you cannot write the first term or the last term as a product of 2 identical factors. So you go with FOIL. FOIL stands for first, outer, inner, and last. So for the first you have 5, and for the last you have 26. And the sum, you know that this is the sum and this is the product, as we have talked before. The sum is positive, the product is positive. So when you're writing the last, both of the factors should be positive, so that when you multiply them, you'll get a positive answer, and when you add them, you'll get a positive answer as well. How can I make 5 by multiplying 2 numbers? It can be 1 times 5. Or 5 times 1. One of them is enough, because in the first term, it doesn't really matter whether you write 5 times 1 or 1 times 5. The order of the factors does not matter, but in the last term, it does. The next thing that you have to try is 26. How do I make 26? The first thing that may be coming to your mind is, I don't know, like 13 times 2. So they should both be positive. So I'm going to write 13 times 2. And then I'm going to try it. This is going to give me the sum, the outer plus inner part. So outer terms are the terms that they're the furthest from each other. So it's going to be 1 times 2 plus 5 times 13, which this absolutely is not going to be the answer, because this is going to be 2 plus 65, and that's going to be 67, and we need 23. So I'm going to go with 1 times 5, and now the opposite, the other way around, 2 times 13. In here, the outer terms are going to be 1 times 13 plus 5 times 2, which is going to be 13 plus 10, which is 23, and that's the sum I was looking for. So I have found my factors now. So I'm going to have 2 parentheses here. I'm going to put the variable here. First of the first parentheses, last of the first parentheses, the order matters. first and last equals to 0. This is the zero product property, meaning when A times B, meaning anything times anything, is equal to 0, it's either A that is 0 or B that is 0 or both. So that's why we say this parentheses times this parentheses is equal to 0. It means that R plus 2 is 0, which R would be negative 2, or 5R plus 13 is equal to 0, which 5R is equal to negative 13. Divide by 5, divide by 5, trying to write it as simple as possible. It's going to be negative 13 over 5. If the question tells you to round it to the nearest tenth or hundredth, you need to find the decimal form, but if it doesn't, that would be the answer. So if I want to kind of like connect everything and tell you something, this means that this graph actually looks something like this if I wanted to graph it approximately without knowing where exactly the vertex is. I would know that A is positive, so it's going to be a minimum graph, because when A is positive, it's a minimum graph. I have two of the points because I know that these are the x-intercepts, or the points where y is 0, so it's actually like negative 2 and 0, and negative 13 over 5 and 0. Okay, so let me get this straight, because mostly I have negative numbers. So negative 2 and 13 over 5 is approximately like 2, it's 2.6 actually. So it's going to be, if this is 1, 2, or let's make these a little bit bigger. So 1 second. We can have bigger units so that you can see what I'm talking about here. So let's say that here is 1, and here would be 2, and here would be negative 3. So negative 2 and 0, this one is going to be here, and 2.6, let's say it's going to be here, and the graph is a minimum. So if approximately I were to graph this function, it would have looked like this, since this is going to be the axis of symmetry, the middle of it, but I don't know what the y would be, because as I said, I'm graphing it approximately. It would look something like this. So in this way, you can actually connect whatever the information you have from before, like how we graph it, what are these points that we find, and everything. And this would make math easier, understandable, and believe it or not, sweeter.